When you step outside on a sunny day, that sunlight just feels normal, right? It's warming things up, helping plants grow. But what if I told you there's a hidden power packed inside that ordinary light? Yeah, really. What if that exact same sunlight could power your laptop, your TV, your entire home? It almost sounds like magic, doesn't it? Well, it's not magic at all. It's science. And a lot of people think solar panels work by, I don't know, trapping heat or something. But that's not it. The real process is way more interesting. So today, we're going to break down exactly how light becomes electricity, step by step. Okay, so how in the world does this all start? How do you take something like light and turn it into power? Well, it all begins deep inside the solar panel, right down at the microscopic level. See, a solar panel isn't just one big thing. It's actually made up of a bunch of smaller units called solar cells. Think of it like a team, where every single cell has a job to do. When you see that grid pattern on a panel, you're actually looking at all those cells lined up, ready to work together. So what's so special about these little cells? The secret ingredient is a material called silicon. You've heard of Silicon Valley, right? Well, this is the stuff. It's the second most common element on Earth, and it's what we call a semiconductor. And that special property is the key. It means light can actually excite it enough to conduct electricity. And that brings us to the most important part of this whole story, the exact moment when sunlight actually hits that silicon solar cell. This is where the action really starts. Okay, so sunlight is made of these tiny, invisible packets of energy called photons. These little guys travel 93 million miles from the sun, and when they finally slam into a silicon atom in the solar cell, bam, they transfer their energy and knock an electron loose. And that's it. That simple little action, a photon freeing an electron, is the birth of electricity. It's the very first spark. We've literally just created electrical potential from nothing but sunlight. How cool is that? So now we've got all these loose electrons just bouncing around inside the cell, which is great, but it's not usable electricity yet. To make it useful, we have to get all those electrons organized and moving in the same direction. This is where the really clever design of the solar cell comes into play. The silicon is specially treated to create an electric field. You can think of this field like a slide at a playground. It grabs all those loose electrons and pushes them down the slide in one single organized direction. And that orderly flow of electrons, well, that's exactly what an electric current is. But hold on, there's a little twist. The electricity we just made is called direct current, or DC, because all the electrons are flowing in one straight line. Here's the problem. Our homes, our gadgets, everything we plug into the wall speaks a different language. They run on alternating current, or AC, where the electrons are constantly switching direction. So we have this kind of translation problem, right? We've got DC power from the panel, but our homes need AC power. So how do we bridge that gap? We need a translator. And that translator is a brilliant piece of equipment called an inverter. Honestly, it's the unsung hero of the whole solar system. It's the critical link between the panels on your roof and the outlets in your home. The inverter's job sounds simple, but it's absolutely crucial. It takes that steady, one-way stream of DC electricity coming from the panels and converts it into that back-and-forth flow of AC electricity that your toaster and your TV and your phone charger can actually use. So once that quick translation is done, the electricity is finally ready to go. It flows right out of the inverter and into your home's main electrical panel, ready to power pretty much everything you own. And just like that, the electricity is completely indistinguishable from the power you'd get from the grid. It can power 100% of your stuff, from the smallest lamp to the biggest appliance. You are now, quite literally, running your life on sunlight. So what happens on a really sunny day when your panels are making more power than you're even using? Well, you've got a couple of awesome options. You can store that extra energy in a battery to use later at night, or you can send it back to the power grid. And in some places, you even get a credit on your bill for it. Okay, so now that we know how it all works, let's just zoom out for a second and appreciate why this technology is so incredible. What makes this whole thing so clean and just smart? Think about it. A traditional power plant has all these moving parts. It's constantly burning fuel, it's making noise and pollution. A solar panel? It has zero moving parts to break down. It needs zero fuel to run, and it produces absolutely zero pollution while it works. It just sits there, silently making clean power. The only thing this entire system needs to run is the energy that's already hitting our planet for free every single day. That's it. And that beautiful simplicity is why solar is one of the cleanest energy sources we have. So let's run through the whole journey one last time super quick. 1. The sun hits the panel, knocking electrons loose. 2. The cell organizes those electrons into a DC current. 3. The inverter changes that DC power into usable AC power. And 4. Your home gets powered up. Simple, elegant, and incredibly powerful. And that just leaves you with one final thought, doesn't it? We figured out how to use the power of a star that's 93 million miles away to turn on our lights. It really makes you wonder, what other amazing solutions are just waiting for us, hiding in plain sight?